When we graph linear equations or linear functions, we know that it forms a line. Whether that line goes through the origin or not really doesn't matter. As long as it's a line, that constant rate of change also has another name. We call that the slope of the line. The slope of the line is the same as the constant rate of change. It is the change in y over the change in x, or the vertical change over the horizontal change. In a linear relationship, the vertical change in y, which remember we're going to show by a triangle y, per unit of horizontal change in x, which we will use triangle x, is always the same. This ratio is called the slope of the function. The constant rate of change, or unit rate, is the same as the slope of the related linear relationship. So again, constant rate of change, unit rate, and slope are all the same in a linear function. The slope tells us how steep the line is. The vertical change is sometimes called the rise. So rise is the same as change in y, or vertical change, while the horizontal change is called the run, which is the change in x. So you can say that slope is rise over run, or change in y over change in x. So take a look at this graph here in the middle. We can see that they have marked 2 points on the graph. One of those points is at 1, 1. Another point is at 3, 4. In order to find the change in y over the change in x, we would look at how does it rise up. It rises up by going from 1 up to 4. It goes from 1 up to 4. It's the second number is the change in y. So we would say the change in y is equal to 4 minus 1. So that the change in y is 3. Then we're going to look at the run. So the rise is 3. And then we're going to look at the run. And we can say that the run is 3 minus 1, or subtracting the x numbers. That gives us a 2. So the run is 2. So rise is 3, run is 2. So the slope of the line, sorry, I forgot to put change in x up here, is 3 over 2. It is also the constant rate of change. So you could put 3 over 2 when you're talking about slope. You want to leave it as a fraction. If I wanted to say that this is the constant rate of change or the unit rate, I would say 1.5 or 1.5. We would not write 1.5 or 1.5 if we're specifically asked for the slope. If we're specifically asked for the slope, we want to leave it as a fraction, even if it's improper, or you can have a whole number for your slope as well. But no decimals and no mixed numbers for slope, because we literally want to have the rise and the run. So take a look at this. This is example 1 on page 75. There are 2 ways we can look at this problem. The first way is, what is the constant rate of change? Remember, we find constant rate of change by looking at the y and x numbers and asking how do they change. This goes up by 1s as we go 1, 2, 3, 4, 5. This is my x number. My y numbers, they're going up by 5s, 0, 5, 10, 15, 20, 25. So I can say my change in y is 5, while my change in x is 1, which would give me a constant rate of change of 5 miles per second. Actually, I lied. That's 5 seconds per mile based on the way they wrote this table. Wow. So they flip-flopped time and distance in this problem. I don't like that, but that's what they did. It's 5 seconds per mile. That is, lightning is going that fast. So let's take a look at how this would look like on the graph. We have 0, 0 graphed down here. We have 1, 5 graphed here. We have 2, 10 graphed here. 3, 15 graphed here. 4, 20 graphed here. And 5, 25 graphed here. Because this is a straight line, I don't have to use every single point to determine my slope. To determine my slope, I just need to pick 2 points. And they have picked point 315 and point 525 as their 2 points to use. So we're going to do change in y and over change in x using those 2 points. The change in y is from 25 to 15. So I'm going to do 25 minus 15 as my change in y. The change in x is from 3 up to 5. So I'm going to do 5 minus 3 for my change in x. 25 minus 15 is 10. 5 minus 3 is 2. I can divide that since it's going to give me a whole number, and I'm going to find that that is equal to 5. So my slope is equal to 5, the same as was my constant rate of change or unit rate. They are the same thing, as I said on the previous slide. Constant rate of change, unit rate, and slope are all the same thing. Take a look here at example 2 on page 76. It says Ronaldo opened a savings account. Each week he deposited $300. Draw a graph of the account balance versus time. Find the numerical value of the slope and interpret it in words. Okay, because we're just given a word problem here, no table, if I were asked to make a graph off of that, I would kind of want to make a table to do it. But first, I would need to know how would I form that table. It says each week he deposits $300. Does it say that he started with any amount of money? No, it just says he deposits $300. So before he started doing that, at 0 weeks, he had how much money? $0. We can come up with a function where y is equal to, sorry, I'm going to have to write it down here. Y is equal to 300 times x, because each week he deposits $300 more. So if x is the number of weeks, y will be the amount of money he has in his account. So after 1 week, he would have $300. After 2 weeks, he would have $600. And after 3 weeks, he would have $900. We can then graph those points on a graph. And you can see that that graph is over here now. This is 1 week, $300. This is 2 weeks, $600. 3 weeks, $900. And it goes up 4 weeks, $1,200, 5 weeks, $1,500, 6 weeks, 7 weeks. It just keeps going up. But to find my slope, I would do change in y over change in x between two of the points on that graph. I'm going to pick these two. The change in y would be 600 and minus 300. The change in x would be 2 minus 1. So you get 300 over 1, which is just 300. Notice that the slope is the same as the unit rate, $300 per week, that we were given in the original problem. But also notice there is no constant in this problem. Notice that this situation is proportional. The line drawn goes through the origin. So $300 is the unit rate. $300 is the constant rate of change. 300 is the slope. They're all the same. In a proportional situation, they are all going to be the same. Because this is a linear function, they are all the same. So not a whole lot of work that you have to do when finding this constant rate of change and this slope, if the situation is proportional. I think when you get to letter B, though, you're going to find that that's a little bit different. I think you should at least make the table and make sure that you are finding change in x over change in y. I see two numbers in there. I don't see just one. Also, I'd like to see if you can write an equation for that as well. You might find that you have more than just a unit rate or coefficient in that one. Okay, so what I would like for you to do is go through right now and do as many of the lettered problems as you can get done, including these. We'll call them E, F, G, and H. And what I would like for you to do is find the constant rate of change or slope on each one. Remember, that's also going to be the unit rate. And we're going to come together at the end of class and we're going to go over these problems. And I would like to spend a lot of time, so I need you to work quickly so that we can spend a lot of time talking about this. Because I have a feeling there's going to be some things that come up, especially if you get to these 4 problems, that are going to throw some people off. So please do your best to get as many of these problems done as possible.